Welcome to Data Unscripted, where we break down the complex world of data engineering and analytics. I'm Ori, and with me, as always, is Daddy. Hey, Daddy.
Hey, what's up?
All is good. Today, we're diving into data architecture patterns. Before we get started and talking about specific patterns, Daddy, why don't we start with the basics? What are data patterns, and why do we need them?
Yeah, sure. Ori, in the early days of data analytics, organizations would just copy data from their production databases into their reporting databases and get going. Simple, right?
Sounds simple, but I sense a but coming.
Yeah, you're absolutely right. It's simple until it gets out of hand, right? So companies started dealing with more data sources, more complex transformations, and more ways of using the data. New use cases like machine learning and all that came in. Right. So you got the raw data coming in from dozens of sources, each in different formats. You need to clean it, combine it, transform it into something that's useful. And different teams with different skill sets needs the data in different forms. So really complex. And the same dynamic happened in software development, as a matter of fact, where the concept of patterns comes from. So you need to be able to scale by having some sort of structure or pattern in place. And this is like the genesis of these architecture patterns.
Okay, so data patterns really allow you to structure the way you're moving data and making it available. I assume it's very related to data quality.
Yeah, exactly. So without a clear architecture, you end up with what I call data chaos. So nobody knows exactly where to find the data they need. There's no clear lineage. We talked about it, of how the data was transformed. And you can't really trust the numbers because everyone's calculating them differently.
Right. So architecture patterns, like the data patterns we're going to talk about, help solve these problems?
Yeah, exactly. They provide a structured approach to organizing how your data is flowing. You can think of them as blueprints that help answer crucial questions like, how do we ensure data quality? How do we track where data came from? How do data developers know where to put their work? Just take the bottom line. How do we make sure our data processes are scalable and maintainable?
Okay. And I assume different patterns solve these problems in different ways.
Right. So just like in software architecture, there's no one-size-fits-all solution. Each pattern has its own strengths and weaknesses and is designed to solve a specific problem. Okay, let's start with the first one, the medallion architecture.
Quite popular recently.
Yeah. The medallion architecture, also known as multi-hop or Delta Lake architecture, basically organizes data into 3 tiers. You start with the bronze, silver, and then gold. You can think of it as a data refinement process.
Sort of like an assembly line from data.
Yeah, that's a nice way of putting it. Exactly. So at the bronze level, you're basically storing raw data exactly as it came in. Logs from your application, dumps for your production database, data from third-party platforms like your CRM or marketing automation. It's messy, but you keep it as a source of truth in your data warehouse.
Got it.
Okay, so moving on to the silver tier. This is where you clean and standardize that data. You're parsing different formats like JSON or YAML. You're converting timestamp to a standard format. You handle missing values, duplicate records, etc. But crucially, you're not yet combining different data sources or adding business logic. So the data is not yet ready for consumption.
Okay, so what you're saying is the gold tier is where all the magic actually happens.
Yeah, exactly. That's where the business value gets created. So gold assets are basically ready for consumption. They have your business metrics, your aggregation, your combined data from multiple sources. So take, for example, customer lifetime value calculations or product analytics that blends user behavior with transaction data. Basically stuff that you can build reports or machine learning models on top of.
Okay, that makes sense. It does add clarity and order to data development for sure, because you know that you're looking at data that is ready to work on. You don't need to develop a kind of another system of how you tag different models or tables that are ready. You have a tier that is completely isolated, and that's where everyone goes to get the data. Now,
Right.
that sounds very reasonable. I've also heard a lot about star schema lately. How does that fit into everything we just talked about?
Okay. So star schema is actually one of the most battle-tested patterns in data architecture. It's a way of organizing your analytics-ready data that's specifically designed for efficient querying and analysis.
Okay, can you break that down for us?
Yeah, sure. So picture a star, okay? So you have the fact table in the center of the star that contains your core business event or metric, like the thing that you're interested in. And you surround it by dimension table that provide context, okay? So take, for example, a fact table that tracks sales transactions, while dimension tables contains information about customers, products, stores, basically ways to slice and dice the data, right? So like sales by location, sales by customer, and so on and so forth.
Okay, that makes complete sense. Why is this pattern so popular?
Okay, so two main reasons. First, it mirrors how business users actually think about their data, right? So they want to analyze metrics across different dimensions. So this pattern organizes the data for easy reporting and ad hoc analysis on top of.
That makes sense.
And second, it's incredibly efficient for analytical queries, right? So modern data warehouses are specifically optimized for this pattern. So you make a SQL, you'll slice the data, you group it, and the data is organized in a way that is retrieved and queryable in a quick way.
Got it. So if this is so efficient for querying, how does that fit with the medallion architecture we just talked about?
Yeah, so they actually complement each other. That's what's interesting. You might use the medallion architecture to process and clean your data. And with your gold layer structure, you put it as a star schema. It's all about combining patterns to solve your specific needs.
Okay, that makes really complete sense now. There's another concept that is gaining traction recently, and people talk a lot about data mesh. It seems that this is a completely different approach to things.
Yeah, that's right. It's the new buzzword at the data town. That's right. So while patterns like medallion and star schema focus on how you organize the data itself, data mesh is more about how we organize our teams and processes around data.
Okay, so it's addressing a completely different type of problem.
Exactly. So take traditional approaches or like org structures that have a central data team that serves everyone. But as organization grows and data requirements evolve, that becomes a bottleneck, right? So the central team doesn't have enough capacity or domain knowledge to serve all the data needs in the organization.
So how does data mesh solve this?
So its philosophy is to treat data as a product and move ownership from the data team or the data organization to the domain teams. So for example, you have the marketing team that's owning the marketing data, the sales team owning the sales data, and each team is responsible for providing high-level, well-documented data products that other teams can use.
That's quite a shift in mindset.
It is. It's a big one. Instead of thinking about data as something that gets handed off to a central team, each domain team thinks about their data as product they're providing for the rest of the organization. That comes with a cost, right? You need to consider the data consumers, provide documentation, ensure that contracts or APIs are not broken, and maintain SLAs when there are data incidents or issues with respect to quality and stuff like that.
Right. Well, to do this successfully, you must have really good processes and guardrails in place. Otherwise, I don't see how this could work.
You're absolutely right, Ori. You need strong data governance to ensure consistency across teams. You need infrastructure that allows these teams to work independently while maintaining your standards. And most importantly, you need to invest in building data capabilities within each of those domain teams.
Sounds like a really big decision that an organization needs to take because it comes with a cost as well as, of course, a lot of upside.
Right.
But let's shift gears for a minute and talk about failure patterns. What are some common mistakes that we see?
Okay, so the biggest one that I'm seeing across companies we talk to is probably over engineering. So you take all those architectures and try to implement everything at once, and teams implement these complex architectures before they actually need them. And then they struggle with maintenance. Okay, so you need to, when you implement an architecture, you need to make sure that this solves the problem that you're experiencing in your organization. Another common issue is treating these patterns as rigid rules rather than guidelines. So every business is different with different contexts, and it's okay to adapt these patterns to your needs. So don't get too religious about it. Start simple and add complexity only when you need it.
That's some great insights. Dadi, I'm sure that there are a lot of religion wars around patterns as well, in the data space as well as the software development space. And thanks for breaking this down with me today. To our listeners, this is all the time we have for today. So thanks for tuning in for another episode. And until next time, keep your data flowing and your pipelines running. Bye-bye.
Talk to you later, Ori. Bye-bye.